Joseph Glorioso's scientific career began as a graduate student at Louisiana State University when he was asked to figure out why another researcher's frog colony died overnight.
So I started out as a microbiologist, but it was interesting because there was also a similar problem at the University of Michigan, and they offered me a job in microbiology.
But by this time, he had developed his own interest in working with the herpes virus in an emerging new field.
About the same time, there was this new thing called gene therapy that had started to come to the forefront. Believed that you could use herpes viruses because they naturally establish long-term persistence in the nervous system as a latent infection, that you could put genes into these viruses. After that, I began to engineer the viruses, try to study their genetic makeup, and pretty soon we had figured out ways that we could introduce the virus into the nervous system.
After nearly 30 years at Pitt developing his research and creating the Department of Microbiology and Molecular Genetics, Dr. Glorioso has co-founded one company and had his technology platform licensed by another.
To have not one, but two startup companies in recent years that have both garnered significant venture capital investment is an incredible achievement.
To recognize Dr. Glorioso's contributions to advancing the field of gene therapy and his dedication to commercializing his discoveries for the benefit of humanity, he has been selected as the 2017 recipient of the Marlin Mickle Outstanding Innovator Award.
I was a full professor when I left Michigan and came to Pittsburgh in 1989 to create a new department. And there was a tremendous amount of excitement and belief that we were right on the, we were right there almost ready to cure all these genetic diseases. So that's kind of where the field is today, that people are trying to engineer viruses which carry genes that will alter the tumor microenvironment, make it less immunosuppressive, create an immune response, and hopefully one day we can even use these viruses systemically. We can inject it into your blood, it'll find the tumors, begin to kill them, and cause immunity to cancer.
One of the herpes virus vectors developed in Dr. Glorioso's lab take advantage of microRNAs that replicate in tumor cells but not healthy cells.
And so this differential expression of microRNAs could then be used to block virus replication in normal tissue but allow virus replication in brain tumors. The company that licensed the technology from us is called Oncorus, Inc. And I'm one of the founders of this company, and I'm also chairman of the Scientific Advisory Board. All of the safety testing has been done, other preclinical studies have been done, and in November we hope to have a meeting with the FDA to begin the process of trying to obtain an IND so that we can actually go into a phase 1 trial.
Dr. Glorioso's wife, Pitt Assistant Professor Paula Grandi, has contributed to the research behind Oncorus and is currently on leave from the university with the company in Cambridge, Massachusetts. The second platform that Dr. Glorioso has commercialized is one that expresses no viral functions.
And so now we have a virus that is completely non-toxic, it doesn't induce inflammation, and it specifically expresses long-term any gene you want in nerve cells. And the uses of this have to do with what the mission of the second company is, which is called Switch Bio at the moment. And the mission of Switch Bio is to use a virus to modulate the function of a neuron. So one of the main targets is chronic pain. So there are millions and millions of Americans that have chronic pain, which is a devastating problem.
The output of Dr. Glorioso's lab has been staggering.
Dr. Glorioso ranks among the most prolific innovators in the university's history. He's in the top handful of faculty all time for the number of invention disclosures submitted, the number of patents he's received, and the number of his technologies that have been licensed.
Glorioso said he is encouraged to see more industry collaboration with Pitt researchers to facilitate commercialization.
Most of the great ideas and most of what we're doing in the private sector comes from academic research. So the two things must work hand in hand. And I think it's only been recently that both the private sector as well as the academic centers are starting to try to work together more so that they can build new products and also discover new ways to treat disease. So there's a lot of pressures in the system, and it's one of the reasons that we have to think more broadly about how we fund research. And the university has to open up a bit and try to attract industry.
Bill Goines was a postdoctoral fellow in Dr. Glorioso's lab at the University of Michigan and joined him when he came to Pitt in 1989.
Now I think they're, with the successes that are going on, especially in the way of gene therapy, which is the work that we're doing, I think in the next 10 years we're going to see product after product after product making it into the clinics.
Glorioso says he's not finished innovating.
I still love science. I still love the idea of thinking of new things, seeing connections. So you have to really make the best possible decisions. What is something that's likely to pay off in terms of creating new science and raising more funds, but also will it make a difference? Does anybody care if you do that? So those are the kinds of decisions that you're constantly faced with.